Hi, my name is Anil Nair, and I'm an aerospace engineering student here at UCLA. And I'm going to help you by going over some math concepts and examples. Good luck.
We're going to go over limits at infinity. So this will take the form limit f of x, limit of f of x as x approaches either positive or negative infinity. So we're going to deal mostly with rational functions. So we'll quickly go over polynomials. So for polynomials, form p of x equals ax to the n plus bx to the n minus 1, and so on and so forth, just polynomials. You take the limit as x approaches infinity of this kind of polynomial, you'll get either plus or minus infinity. And that'll depend on, if you look at the leading term, that's the term with the highest exponent. If it has a positive coefficient, you'll get positive infinity. If it has a negative coefficient, you'll get negative infinity. And same if we go to if x approaches negative infinity. You'll get positive or negative infinity. This time, whether you get positive or negative is a little more tricky. If you have an even degree, so your leading term has an even power, then you'll get, then you use the same rules as before. You look at the leading coefficient. But if your leading degree is an odd number, like 3, 5, 7, or 1, then you'll flip the rule. So if you have a leading coefficient that's positive, you'll get a negative. You'll go to negative. If you have a leading coefficient that's negative, you'll go to positive infinity. So that's that. So now we're going to deal with rational functions. So that's going to take the form f of x equals p of x over q of x, where p and q are polynomials. So there's three cases. The first case is if the degree of p is less than the degree of q. So we have a higher degree on the bottom. So for example, that would be 2x to the third plus 1 over 2x to the fifth plus 1. We have a higher degree on the bottom. In that case, the limit as x approaches infinity, positive or negative infinity, is going to equal 0, because the bottom will get bigger and bigger, whereas the top doesn't grow as big. Our second case is if the degree of p is greater than the degree of q. So the top grows bigger than the bottom. In that case, the limit as x approaches plus or minus infinity of f of x will equal either positive or negative infinity. It doesn't exist. The way you determine if it's positive or negative infinity is that you again check whether the degree is odd or even. If the degree on the top and bottom are both odd, if they're the same type, like if they're both odd and they're both even, then you will get positive infinity if you're going to positive infinity, negative infinity if you're going to negative infinity. This is assuming you have positive coefficients. If you have negative leading coefficients, then that flips as well. And then if they are opposite, like if one is odd and one is even, then you flip those rules. You won't run into that most of the time. If the degree Sorry, I wrote dep. Put deck. Okay. If the degree of P equals the degree of Q, then the limit as x approaches plus or minus infinity of f of x will not equal 0, and it'll equal the ratio of the leading coefficients. And here too. So I'll give you more examples. For the degree of p being greater, we can just do 2x. 2x to the fifth plus 1 over 2x to the third plus 1. And for this example, we could just do 2x to the third plus 1 over 3x to the third minus 2. And what these will look like graphically is, this will approach 0. This will go off into infinity. And this will settle on some value. So another good thing to know for limits at infinity is for exponentials. So the limit as x approaches infinity of e to the x, which is also the same as the limit as x approaches negative infinity for e to the negative x, equals infinity. So it does not exist. But we say it equals infinity, so we know we're talking about if you multiply it by a negative constant, you'll get negative infinity. And then the limit as x approaches negative infinity of e to the x, same as the limit as x approaches infinity of e to the negative x equals 0. We can see this by looking at the exponential function. As we go positive, it gets higher and higher. As we go negative, it gets closer and closer to 0. And those are pretty much the rules you need to deal with limits at infinity.